And through the miracle of modern webcasting, we're done. So what we want to do is we want to watch two things. We want to watch the indicators that we just created on our front panel. So let's resize our front panel to show them. And we want to see the output of our lifter type def. So if we double click to show that global, resize the global to see just those parameters that we care about. Then we can actually debug and watch in real time as we run. One of the really nice things about doing this is because we've cased out all of the hardware calls, we can actually run this code even if we're not connected to the robot. One of the ways to do that is by right-clicking at the very bottom here where it shows the robot name, and instead of choosing the project which contains the FRC robot, choose Main Application Instance. When we choose that, we see a new front panel opens, but it doesn't show the project name at the bottom. That indicates that it's running on our local computer. So if we show the block diagram of this screen, it's going to replace the block diagram we had before, which was intended to be targeted on the C-RIO. Now that we've done that, double-click to see the simulate mode, and be sure to turn that value on in your global variable. And then let's just scroll in our global variable till we see the parameters we want to watch from our lifter type def. So now turn on execution highlighting, and we can actually watch as our state machine executes. We see that our initial state is start, as we expected. Our command signal is 0 and false, which is good. Our simulate mode is true. Our three booleans are false. So we immediately go into the start case. Our output speed has been set to -0.5, and our new state is moving down. Then as we watch, we see we go into the moving down case. Again, everything in our while loop will run over and over and over again. And remember what the moving down is waiting for. It's waiting for a lower limit switch value. Because it's reading false, it's continually going into the false case. So let's push that value on the lower limit switch. And then next time through the loop, we see the true gets picked up from the Boolean control, gets inserted into our type def, into our cluster, and now our motor speed has been set to 0, stopping the motor, and our state has been moved to wait for ball. So we see the wait for ball case is again false because the ball sensor hasn't been tripped. So if we set the ball sensor true, then the next time through the loop, that value is true, gets inserted into the cluster, and immediately our delay is activated, and we go to the delay before raising state. Of course, our global variable is updating for us. Our speed is set to +0.5. Our state is moved to moving up. And next we're in the moving up state. One of the tricks to this kind of simulation is keeping track of the digital inputs that you're simulating. For example, now that we've started moving up, if I'm going to properly simulate, I should probably turn off the lower limit switch. And I should probably turn off the ball sensor. It's important to do that, otherwise when you're testing, you're going to find that you're cycling over and over and over again. Because in real life, these switches will turn off. So we're moving up and we're waiting for the upper limit switch. So if we trigger the upper limit switch, And we see our speed is set to minus 0.5, we're moving down again, and the whole loop has restarted. Now there's no reason you have to have execution highlighting turned on through this. In fact, it's a lot more interesting to watch when it's not. So if we go from moving down, as soon as we hit our lower limit switch, boom, we're waiting for ball. As soon as we hit our ball sensor, delay, and then moving up. As soon as we hit our upper limit switch, moving down again. So you can execute this very well. Now the other thing we can test now is let's go to our command signal and put it in manual override. As soon as we did that, notice that our speed went to 0. And if we put in a value here, simulating the teleop mode, we see that that value is going right into the output speed. And if we turn off our manual override mode, and then navigate back to this part of the shifter, we see we've gone into the moving down. Now we've actually gone to the start and then to the moving down case. It just happened so quickly that we couldn't see it. So this is a really nice way to test the logic of your state machines without risking damage to life or limb or to the robot. Thank you very much for watching this video. There have been several pop-ups throughout this video which, for subscribers of the lvmastery.com online training, will drill you right into the training material relevant to that particular section. Remember that these introductory videos are intended to get your feet wet and get you introduced to LabVIEW. There's lots to learn about LabVIEW, and we're very proud of the lvmastery.com online learning experience. We've had a lot of great feedback from other FIRST team members and other high school students who have taken the training. I'd also like to mention the Buy One, Give One special offer for mentors, teachers, and parents associated with FIRST teams. We're allowing anyone who's associated with the FIRST team to purchase the LV Mastery online training for the academic price of $500 for all 3 courses. And for anyone who takes us up on that offer, we'll donate a training seat to a member of their team as well. Thank you very much for watching. This has been Ben Zimmer from lvmastery.com. Bye for now.